How's it going, everybody? You're here with Joanna Kwansoon and Daniel Brockenbrough Johnson. And we're presenting to you a Husky engine modeled in CATIA VR5.
Today we're going to walk you through some processes that we use to design some of our parts. The workbenches identified on the screen shown would be the part design, generative shape design, and assembly design. And some of the common tools used in addition to the ones shown there are our sketch pad, hole tools, as well as fillets. And these are common phrases that will be used throughout the process as we walk you through our design.
So Joanna and I chose a couple of parts to discuss in detail. The first part we're going to discuss is the cylinder. The first step was to define a base sketch, and this was done by using the circle tool and then constraining it with a specific diameter. Once that sketch was done, we exit Sketcher and pad it. Now, the base sketch is white because it's not fully constrained, and we'll go into detail about what's fully constrained and constrained later. The next step was to define this cylindrical tab on the bottom of the cylinder. Once again, we enter Sketcher, and using the circle tool, we draw an arbitrary circle, define the diameter. However, we use the outer edges of the previously created cylinder as a reference element, and we constrain both that circle and the created circle in Sketcher to be both concentric. This is why that sketch is green. And then we would pad this sketch out. So the next step was to define this flat face detail of the cylinder. The area here where there's a 9 was defined on one of the drawings, and it was a known distance away from the edge of the cylinder. We once again use the reference element tool using the prior created surface of the cylinder, constrain the line coincidence, hence the O's, and we pocket this surface out to create the surface on the right. The next feature to be defined were the drill and tap holes. So on the surface of the cylinder on the very top, we use the hole command to set an initial placement of one of the small holes that will go around the circumference of the cylinder. It's an up to next hole, so there's no dimensioning needed. And the circular pattern tool was used to create all 8 instances of that smaller hole on the right. The next feature was a very simple feature, the cylinder center hole. We used the hole command to initiate this feature, and one tip and trick that we used was to click the outside circumference of the top of the cylinder and the surface that the hole was going to be on. And what that does is it makes the hole position concentric with that circle. That way you don't have to use a positioning sketch. This next feature was also a very simple one. We once again use the hole tool, and this time we use it on the flat surface of the cylinder. This time we need to use a positioning sketch to actually place the hole. And the figure on the left is just an illustration of where we are in the spec tree, showing you the steps. So once again, we started with the base cylinder, cylinder tab, flat cylinder, detail, the 8 instances of the small holes up top, the center hole, and then this surface. The next part we'll discuss will be the piston rod. This was an interesting part because the length of the piston rod wasn't necessarily defined on the drawing. It just had to meet the tolerance of not being so long that it goes through the piston, or not being so short that it falls out of the piston. So similar to the cylinder, the base sketch here was defined by using the circle tool. The diameter was constrained, and once again it's white because it's not constrained to anything else. Once the sketch was made, we used the pad tool. The next step in this modeling process was to create the piston top. Here in Sketcher, a point was concentric with the initial base sketch. A construction line, which is this dash line here, was created to be coincident. The next step was to make a circle that was also coincident with that line, and it was known, the distance between both of those circles was known and then constrained. Just like before, the pad tool was then used. Here, the primary length of the rod is defined by first using both of the previous sketches as reference elements, and then using two tangent lines on both of these circles, and then using the eraser tool to take away the top and bottom portions of the cylinder, so only the middle part is left. Once again, the pad tool was then used. Here, the rod tabs at the top of the piston rod were created. Each of these circles are concentric with the upper semicircular part of the rod, and the pad tool is used. The final feature was to define the hole that goes into the bottom of the piston, and this was simply done by using the hole command, clicking the surface of where the hole was going to be defined and the outer circumference, therefore making the hole already concentric. That way we don't have to make a positioning sketch.
Hi guys, I'm going to start you off with the cylinder head, and then first we're going to take a quick look at the spec tree before I get into it. We see the shaft command, the hole command, a circular pattern command, a pocket command, and then a fillet, and then we have some rotation commands at the end for creating our best view. So we're going to start quickly with our sketch command. Just creating the base sketch, which we will be rotating around the z-axis. As shown to the image on the left, we did apply a lot of constraints in order to make sure that our base sketch wasn't moving so that we could properly apply that rotation command. Next, we were inserting the hole into the cylinder surface. The engineering drawings that you will be provided should identify the specific location of that hole, and you should be able to create a circular constraint line as shown in the image on the right. Once that line is defined, you should be able to plop or constrain your hole from your hole definition command onto that line and position it accordingly. And then once that's done, you simply have to set up your hole definition and select how far you want that to go through your surface. Once that's done, you simply take your pattern definition and you replicate those holes using the instances. The instance counts that first hole that you initially put in the slide previously, so we're counting that as 8 holes for a total of 45 degrees per hole spacing. And once that's done, it's a simple matter of previewing to ensure that's what you're looking for and then executing that command. Next, we will add the cut. A simple way of adding the cut would simply be to create a chord at the end of your surface where you desire to have that cut. You can also just create an awkward shape at the end that identifies that 9, in this case would have been 9 millimeters long, but as long as you had a definition and constraint to that surface, applying the cut command. One key note here is that if you reverse the direction as shown on the right image, that orange arrow, if you were to reverse that direction, it would actually flip the cut and you would end up with that small edge of your overall shape instead of that larger cylindrical shape that we see for the cylinder head. And last but not least, one of the final steps would be adding the fillets. Adding fillets is relatively simple. You simply identify your edges. You can select multiple edges all at once if you're selecting edges to have the same fillet. In this case, it was simply one edge with a fillet of 0.75 millimeters. And once that was done, I applied some rotation commands, which is relatively simple. On the right, you'll see the x-axis, on the left, you'll see the y-axis. And that was simply rotation commands in order to align my view to the best view for anyone who would open it and take a look at what was going on. And then next, we will move on to our piston. Next, I'm going to go over the process for creating the piston. Identified first again would be my spec tree. You see on the left my pad command, the hole command, the external groove, the rectangular pattern, the hole, and then the mirror command. The next step will be creating the base definition. For this purposes I chose the circle, although there's another form of doing this, which would have been creating a shadow command with all the other parts already included. But we're going to start with the base. The next step would be to, after padding that base, would be create your counter sinkhole. The definitions of the hole itself can be found in your engineering drawing, and you can simply apply that definition in your hole command once your hole is already constrained. Moving on, we will next be able to create our groove. There's a groove definition command in CATIA, and once you open that up, you're able to define on what plane you'd like your groove to start. In this case, you can see that I had been working on the ZY plane. I insert the position of my groove, and on the left hand side you can see that I follow through with a 360 rotation of that groove on that surface, and I was able to do a complete groove for that surface. In order to create that pattern, we apply the rectangular pattern as identified earlier in the specification tree. And that was a simple process of selecting the rectangular pattern and multiplying that for 4 instances, as shown earlier when we had applied the regular instances for the cylinder head. Once that's applied, our next step would be to insert the remaining hole in our piston. In order to do this, the best way that I decided to do it was to work in the ZY plane, defining a hole command through the ZY plane and extruding that hole up to the next surface as seen on the left under the hole definition tab. And once that was done, it was easily mirrored using the mirror command on the other surface of the piston, and there we had our completed part. An alternate form of adding holes to surfaces would have been to use the GSD and create a plane as shown in this image here. We would be able to define an element as shown on the left along the curved surface, and then on the right using that element and the surface itself to create a plane, and then inserting the hole on that surface would have also been something that would have been possible on the last positions of the piston. Here, that would have been also possible if we had inserted surfaces on the tangential surface of the piston. Okay guys, thanks for listening to our little spiel about the engineering drawings and how we got to our little Huskey engine as shown before. Let us know if you have any comments or if you have any questions. Thanks.